So for our background, we were tasked with making a precision launcher using a 5-pound weight, and the projectile had to be a foam-like material, and it had to hit a target 30 feet away. The design couldn't be a simple catapult. It had to be something more complex, but it couldn't have anything else to force it besides the weight. And then at FEDD, we were scored by how far the projectile went, as well as where it landed on the target. Our initial design, we had initially planned to do something that involved like a pulley system. We would like drop the weight and it would fling the ball. The design was clearly impractical as we moved forward with it, and so we decided we need a new one. So for our revision, we decided that we shouldn't let the pulley absorb most of the energy and weight in hopes that it would fling the ball, so we wanted the more efficient means of launching the ball. So we thought of a traditional slingshot, and we modified it so that it would involve the 5-pound weight. And we used the strong elastic, which can store lots of potential energy, and pulled it back with tension. It provided the force needed to launch the projectile a reasonably long distance. So for the final design, we settled on, it consisted of a large slingshot drawn back by a mechanism and held by a mechanism that would release the sling upon having the weight dropped upon it. This mechanism would be at the bottom of the inside of a PVC pipe and consisted of 2 wooden platforms held together by 2 springs, and the bottom platform would be fixed in place and then the top moved freely. So then continued, we have a nail sticking out of the top one, which the wire attached to the box loops around. And after hooking the sling onto it, the weight is dropped at the top of the PVC pipe, and that causes the top platform to go down and the box to release, which would make the projectile go. And so my advice for incoming freshmen is to not wait until halfway through the semester. Even if you have to be the one to reach out, just reach out. And I guess plan early and plan simple. Do something you know is gonna work. And yeah, have fun.
The first thing we made was the base of the launcher. So we just screwed together 2 large pieces of scrap wood to make it heavy and sturdy. The next thing we did was we attached the arms of the slingshot. At first, they were really wavery and they wouldn't support the weight of being pulled back very easily. So a person at the craft center advised us on how to attach these little blocks of wood, as you can see here, to the arms of the slingshot as if they were the legs of a table, which did work and was very useful. The next thing we worked on after we got the basic structure of the launcher was we started to make the actual sling. And originally we were going to have a piece of mesh cradle the projectile, but the mesh, after we sewed it onto the latex tubing, tore and was obviously not going to work. So then we regrouped and we replaced the mesh with a little wooden box that we made. After that, we drilled 2 holes in the bottom of the box to loop the wire through that would pull it back. So we also had a problem with the springs and the mechanism, which was one of the last things that we made. We got advice from Dr. Adams on how to do that, and we essentially inserted small pieces of wood into the springs and screwed that onto each wooden platform, which worked. So
That's it?
That's all from me. My advice to freshmen is to make use of the craft center for a lot of the more mechanical projects, not necessarily stuff that you do with like coding, but if you need to use the craft center, make appointments ahead of time, and it's a really valuable resource. That's all.
We had to make many improvements to get the projectile to launch 30 feet. So the first thing that we had to change was the dimensions of the box. So when we first had the box made, parts of the sides were too long, and so what would happen is every single time we threw the projectile, it would catch itself on the box and actually go backwards. And so once we attached the box to the wire and the screw, it would also face downwards as well, and that also allowed gravity to drop the ball before we could launch it. And so what we did to fix this was we tied the wire higher up along the back of the box, and that allowed the box to be at an upwards angle. And then also, in order to fix the box catching itself, we cut off the sides to make it a better angle for the ball to launch and not catch itself on the box. So for our final product, once we figured this out, we figured out that the ball was able to go 25 feet, which meant we did not reach our goal, but it was still sufficient enough to at least get us a percentage of the points at FEDD. So at FEDD, we ended up starting off with a misfire, which caused a little bit of panic, but we realized it was just because we dropped the weight incorrectly, which caused the ball to catch itself and launch backwards. However, though, on the second try, we hit the second circle on the target, and we almost got it into the middle, which was exciting. And our other two attempts were short. We realized we should have moved it a little bit closer to the target after. In retrospect, we did not end up getting scored at FEDD for unknown reasons, but we realized that we could have done some things better in order to get a better score. We could have determined the average distance launched by taking 10 trials, measuring and averaging, and that could have saved us a few points in getting the right distance from the target. And we could have also continued moving up the wire loop on the box to get an even better angle to make it go further. Advice for freshmen. So the biggest piece of advice would be time management. Our group had good time management across the whole period, and we were still working until the very last day. This means that there should be meetings consistently, and the group should make their own deadlines to get specific parts of the project done. This will keep the group less chaotic and will allow time for the group to make adjustments if something in the project goes wrong unexpectedly. And those are our references from research.